Here we're going to talk a little bit about instrumentation amplifiers. Instrumentation amplifiers are basically combinations of operational amplifiers that are wired together in a way that has some very useful properties to them. Now this is actually a simplified diagram for an instrumentation amplifier, but going through and analyzing this would be a bit complicated to say the least. The important thing is that there are two op amps at the inputs, which act to some extent as buffers and help clean the signals a little bit that are coming in, and then another op amp downstream which takes those signals and multiplies them, and takes the difference and multiplies that by a certain amount of gain and produces our output voltage. Now when put together like this, there are a couple, as I mentioned, very useful properties. One is that you can get very high gains out of an instrumentation amplifier, and you do so by changing the value of one resistor. So there's this resistor right here called R gain, and depending on what you set that to, it will determine what the overall gain of the instrumentation amplifier is. The other property is that it has high common mode rejection ratio, which basically means that if there are fluctuations that are common to both inputs, up or down, those are very, very highly rejected from the output of the instrumentation amplifier. So if you have a small signal that's imposed on a large signal that's fluctuating together for both of the inputs, that large signal will be removed from the amplification circuit, and just the small signal, the small difference that's laid on top of those between the inputs will be amplified. Now there are lots of different ways to construct an instrumentation amplifier, but luckily there are also lots of different kinds that you can buy, and one of the more common ones is the AD620, which is shown here. So similar to an op amp, we have an input, a negative input terminal, a positive input terminal, a negative voltage source, a positive voltage source, and an output. We have two pins on this particular amplifier that are labeled RG, and that means that if we connect a resistor across them, that allows us to set the amplification for the instrumentation amp. For this particular amp, the formula is given as gain is equal to 1 plus 49.4 ohms over Rg. So you can just figure out what gain you want, put it into this equation right here, solve for Rg, and put Rg into your circuit, and voila, you end up with the gain. There's also a pin labeled ref, and that allows us to basically subtract off a reference signal before we do the amplification as well. So if we have a constant background voltage, we can put that into feed that into the reference pin, and that's subtracted off of the voltage before we do the amplification.